All right. Hey, you guys should, after class, exchange phone numbers and hang out later so you don't have to talk during the whole thing. Okay. You don't have to write this part down. I just know that it's been hard for me to get back into, like, what are we doing? So I imagine it's hard for some of you, like, what did we learn before this? Okay, we've talked about circles specifically. In the bell work, we reviewed what a chord is and what a tangent is. Tangents are hard for me to draw. What else have we talked about? Well, we've done in central angles. So if this is 45 degrees, what's the measure of the arc that it intersects? Also 45 degrees, so we've talked about these arcs. We've talked about if we have two chords that are equal, then the arcs that they create are equal. Anything else that you can think of? Our least favorite thing, I dare say, we had a tangent, and we had part of a secant, and it created a 90-degree angle, and we had to find the radius. Do you remember? So so looking at your paper, we've done a lot with circles. So I kind of want you to be remembering. No, today we're doing the bottom four. Okay. Tyler, how many degrees is it all the way around? That's important to remember. Ethan, how about if I have a diameter? What is the arc of a diameter? Okay. Some of these things are going to come up today that aren't really a part of the lesson because, right, the lesson is assuming we didn't just take a week off. So these are some things that it expects you to remember. Okay, do not write these down. We are going to talk about inscribed angles, inscribed triangles, inscribed quadrilaterals. So we need to review some things that we should know about triangles and quadrilaterals. So just look at these for a minute. I'm going to call on some of you to see if you could help me figure out, like, what do we know about them? How could we find these missing parts, okay? So Paxton, if I pick on you first, which one would you choose? Which one do you know the most about? Would you try to find the stuff in number 1, 2, or 3? What do you know about triangles, about the angles in a triangle? You're not sure? That's okay. That's why we're doing this, so we can remember. Ambrose, what one would you try to solve? Do you know much about any of these? Yeah, what do you know about the triangle? What do all their angles have to equal when I add them up? Yes, so we're not going to solve this, but I want to make sure that we could add 3a minus 2 plus a plus 2a minus 16. And since there's only a's, you could equal it to 180. Now, if you are like Paxton, you maybe didn't remember that. I would jot that down at the top of your notes page or formula page on your actual notes page, that a triangle angles equal 180 degrees. If you already knew that, it's just we refreshed it. If you really weren't sure, I would write it down. So we could add them up, we could equal them to 180. All right, Martha, what about the quadrilateral? How could we find, like, the x here? I wish they were equal. They definitely, this one's obtuse, this one's acute. Yeah, Bradley. Why do you keep saying 180? I'm just wondering. So you're thinking these would be 100? So that might be true. It didn't tell us these are parallel, though, so we can't assume these are supplementary. Okay, here's my shortcut. If you know that triangles are 180, any quadrilateral, you can do this too. That's supposed to be straight. What did I just create? Two triangles. So what's the sum of all these angles? Yes. If you can't remember all, you can do this with any shape. Why couldn't that come out? Any shape that has any number of sides, you can turn it into triangles to figure out what the sum of the angles are. So the sum of a quadrilateral is 360, but if you don't remember that, make it into triangles. So you might be right. These could be parallel, which would make these supplementary, but we don't know for sure. What we do know for sure is if I add them all up, kind of like number 2, they would equal 360. Okay, let's look at the third one then. It seems like we have some missing information. What do you guys think? Like I just have 2 equations. We know they're parallel, yes. These little triangles are like a symbol for parallel lines. So this is a trapezoid. What else does it tell us? Yeah. Yes, which is going to get us closer. What do these mean? So we have an isosceles trapezoid, which has other theorems. So this angle, because it's an isosceles trapezoid, these 2 angles are equal. These 2 angles are equal. So you can do lots of things. You could do 2x plus 7, and you do it again, plus 2x plus 7, plus 4x minus 1, plus another 4x minus 1 would equal 360. So again, these are just reviews of shapes. You may or may not remember that, but it's assuming that we have some prior knowledge, okay? All right, Levi, will you read the essential questions here? And again, you don't need to write these down. We'll start writing on the next slide. So within our essential questions that we're going to be answering today, we don't know right now what an inscribed angle is. We don't know yet what their intercepted arcs are. And we've also never seen an inscribed quadrilateral. So those are the 3 things that we're going to be learning about today. If you look at the next 4 theorems, they have to do with inscribed angles and inscribed shapes. So this is not a theorem. This is a definition. But I kind of wanted to put it on my paper. So I turned it over, and there was some room on the bottom. You can put this in your notes if you want, but I wanted it on my paper. It's really hard for me to do the theorems if I don't remember what an inscribed angle is and its intercepted arc. So again, you can put this down wherever you want. I chose to put it on the back in that empty space because I can use this on a test. So let's read through this while you're trying to write it. Do you have yours? Where's your paper? Oh, I have one left. This could be a problem. You don't know where yours went? Did you want to check your backpack? Okay, turn around. Oh, good. Okay. Inscribed angle, let's start with that. The angle that we previously did was a central angle, so it is different. A central angle, the vertex is in the center. An inscribed angle is an angle whose vertex is on the circle and its sides, so here's one side of the angle, here's another side of the angle, they contain a chord, and that chord creates this intercepted arc. So the pieces kind of go together. So what's a non-example then? If I've got a circle, it's just getting worse. Let's try it again. And it's a vertex, and I've got one side, but my other side is going outside the triangle. This is not an inscribed angle. This is not an example of that because both sides have to head through it and create a chord and an inscribed or an intercepted arc. So one way I try to remember these words, I keep wanting to say an intersected arc because we talk about intersections on the grid. An intercepted arc, so I was thinking about football and like a football route. So if somebody's running along this football route and they're going to catch a ball from the quarterback, and another person is coming this way and they intercept it. That's how I'm kind of remembering that word. Basketball and football has interceptions. Do any other, I guess lacrosse and hockey, you can intercept in a lot of sports, huh? Soccer. What's a sport you can't intercept? Golf. Correct. Baseball, if the other team intercepts it, they just get themselves out, right? That's funny. Like if your friend's running the bases and they intercept, you're out, right? Okay, sorry, I should let you guys write. An inscribed angle, thank you. Just snuck up on me. An angle whose vertex is on the circle and the sides contain a chord. Do you need paper or something? Okay, so once you have this inscribed angle and this chord, it creates an arc. So that arc that's created is intercepted arc. An arc that lies between two lines, rays, or segments is called an intercepted arc. Now, I did not write this part down because I haven't seen it come up anywhere else, this sub 10. So I kind of stopped right there. I haven't seen that moving forward. So if it's important, we can come back and put it in, but I did not put that part in mine. Subtend. The chord is said to be subtended. So the subtend is just talking about the relationship between this chord and its arc. So this arc subtends the chord and the chord subtends the arc. I don't know why that needs its special word. Okay, I'm going to see where we're at with writing this fun thing down. If I go on from any of these theorems and you are not done writing them, once you start on the homework, please just come back, and you're welcome to move through the slides, or you can borrow my paper and get them written down.
So the inscribed angle, it's only inscribed because there's the intercepted arc. Like if the arc wasn't there, would it still be inscribed?
Yes, the thing that makes it inscribed is that the vertex is on the circle, as opposed to our central angle. You notice they end at the same spots, but they have a vertex in the middle. So central angle we did before spring break, and inscribed angle, it's where the vertex has moved to. I think that's the main difference. Okay, this is my favorite one. This one's not easy to remember, but it's kind of fun. It's just half. So this one is on your paper. It's the fourth one down. Fourth one down. Zara, will you read it for us?
The measure of an inscribed angle is 1/2 the measure of its intercepted arc.
We love that, right? That's so easy. So if the arc is 100, the angle is 50. If the angle is 50, the arc is 100. So this angle ADB is half the measure of the arc. I love that. And the picture is very helpful. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. So the picture just has the one angle, and this is very useful. If you don't write that part down, the picture doesn't do you any good. So, Gracie, if they give me the measure of the arc, if they say the measure of arc AB is 90, what's the measure of the angle? Oh, Macy. Told you, Gracie. If they tell me that the measure of the arc is 90 degrees, what's going to be the measure of this angle? We do half. Well, what if they give us the measure of the angle? So that's not true anymore. So what if it goes the other way around? Jetta, how would I find the measure of the arc? Yeah, you'll double it. People just kept halving it. In my last class, they were like 15. It's not always half. It just depends on what they give you. So if they give you the angle, you'll double it to get the arc. If they give you the arc, you half it to go back to the angle. Okay. So here's some example. You don't necessarily need to write this one down, but I do want you to think of the answer in your head. And I'm going to call on some of you to tell me what you think. So we've got a couple different inscribed angles. That Z is creating two inscribed angles. The first one asks us to find the measure of angle T. So that's this one here. Ashlyn, how would you find the measure of angle T? Yep, so what would it be? Yes. Okay, now we've got another part. They want us to find Q, arc QT. And that's a lie. Arc QR. I wish that's what they asked me to find. I know how to do that. Arc QR. Jeremy, how might you find that? Yeah, how would you finish that? That's definitely part of it. They didn't ask for that, but we need that. Did anyone else see it? Miles? Semicircle. So this is what I mean. There's some things in today's homework and today's lesson that we reviewed this now, but I didn't teach it to you just 2 minutes ago. We learned it like 2 weeks ago. So if you get stuck, look through your notes, ask a neighbor, see if somebody else remembers, because Jeremy was definitely on the right track. We have to know this piece. There's a diameter, so that might be foggy. Yeah. It is. Yeah. Okay. Let's do one more kind of like that. Unless you really want to. I don't know. I think the example on here is good. All right, so here's this picture. They want us to find the measure of arc RS. So think in your mind what you think it is. Don't say it out loud. Sarah, how would you find that? Yep. 31 times 2. Perfect. This is an inscribed angle, so it's going to be half the measure of its intercepted arc, but we're going the other way. We're doubling it. Okay, now they want us to find STR. They want us to find this angle. You got it? What do you think it is, Tristan? How did you know it was 31? Yeah. So if you follow it out, it has the same endpoints as angle U. So I can use the same idea. It's half the measure of its intercepted arc, 31 degrees. Did you guys notice that they share these same endpoints? Okay, that's actually our next theorem. Our next theorem is inscribed angles of a circle theorem. So it's this one here on the right. And Tristan, will you read it for us? So you would probably, like we just did a minute ago, figure it out, but this is a shortcut. So you can just go right to their equal. If two inscribed angles of a circle intercept the same arc, so they've got the same endpoints, then the angles are congruent. So the ones they're showing us, these are the endpoints. So we've got one angle inscribed there, and another same endpoints inscribes here. There's actually two sets on this. So if you also notice that angle D, or excuse me, point D and point C could also be endpoints, and would bring you to angle A would be equal to angle B. So you can go either way when you've got this hourglass kind of picture in there. So again, also angle A is congruent to angle B. That's also true, because I'm headed that way. That one didn't take as long to write, did it? Is it hard to believe we have two more of these? Oh, you would not be ready, though. You're full of good ideas. You should be a teacher someday. Okay. So if you use the shortcut, let's look at the picture. I don't expect you to write these ones down necessarily. I just don't, unless you really love the examples. So given the measure of angle E, we can see it's labeled 75. Find the measure of angle F. So think it in your head. Some of you whispered it before, but you're not supposed to say it out loud. Delta, what would be the measure of angle F? Right here. You've been writing and not processing? All right, CJ, how would I find it?
75.
It is 75. So if you weren't paying attention, you could double it. You could double this and find the arc, and then half it and find the angle. You could go through that process, right? This theorem was not necessary. It's an extension of the other one. This is just supposed to be a shortcut. So if you have two inscribed angles, which we do, they both have a vertex on the circle. They both go through it, and they share a common intercepted arc, which they do, then they're equal. That was a shortcut. But again, if you forget that one, you double it, and then you half it. There's other ways to get there. Is there another example? There's a couple more. Okay, these are going to review the theorems that we've already talked about. So again, don't yell out the answers. I want you guys to all think about them. Let's look at number 1. Where did I get to? Lindy, how would I find the measure of the red angle on number 1? So HGF. Half of 90. Because it's an inscribed angle and it's intercepted arc. I feel like Andrew, let's look at number 2. How would I find the measure of this red arc? Double 38. Can you do that in your head? That was impressive. It's an inscribed angle, and we've got an intercepted arc, so the angle is half the arc. The other way around, it's twice the angle. All right, let's look at this third one. Zara, you only read though. Zara, how would you find the measure of this red angle? ZXW. Yes, so if you don't remember the shortcut, You could always double 72 and then half of 72. But if you remember it, it's just a short way to get there. Any questions on these three? Maybe, maybe not. Sometimes I noticed on the homework it won't give you it there. It'll give you like, how do I explain this? It'll give you that one, and then it'll ask you for this angle. So they're not always super straightforward. How in the world would I find the angle if they gave me that? Logan? And so this is 180. So you kind of see, and then you can half it. But sometimes you can't just go half or double. Sometimes you've got to look around. The whole thing is 360. There's a little bit of super sleuthing happening. Okay. These are the last two ones you have to write down. So I'm going to talk you. If you can shorten it somehow, the stuff that's written down, shorten it. Sometimes you don't have to write every single word for you to remember what it's saying. So let's see what it is saying. Bradley, will you read the top one about inscribed right triangle theorem?
Right triangle inscribed in circle is diameter. Conversely, one side is inscribed triangle with diameter is circle and the triangle is right triangle with an angle opposite the diameter is right.
That's a lot to write in a sentence. This, if and only if, when he got to the middle of that, he said conversely, it just means it's that revolving door. So you can start knowing it's a right triangle and conclude that the hypotenuse is the diameter. Or you can go backwards. You can start knowing that you've got a triangle with one side as a diameter and conclude it must be a right triangle. It can go both ways. The word inscribed triangle set means that all 3 points of the triangle are on the circle. So that word inscribed means that all 3 of the vertices are touching the circle. If a right triangle is inscribed in a circle, so we have to know this is a right angle, we know that, then the diameter is the hypotenuse. Or you can go backwards. If there's a triangle that's inscribed and one of its sides is a diameter, we can conclude it's a right triangle. It can go either way. Know the 90, it's a diameter. Know it's a diameter, conclude the 90. Okay, if you've moved on to the inscribed quadrilateral, that word inscribed means the same thing. It means all 4 vertices of your quadrilateral have to be on top of that circle, all 4 of them. And this one's super short. If you have a, here, I'll pull it up a little bit. A quadrilateral can be inscribed in a circle if and only if the opposite angles are supplementary. My Math 1 class is learning about triangles and angles, so it is on my board over here what supplementary angles are. They have a sum of 180. So what does it mean to be opposite angles? Luke, if you're looking at that quadrilateral, what are the opposite angles? Yeah, so opposite just means they're not the next ones next to one another. They're opposite. So as it says here, D plus F equals 180. Also, E plus G equals 180. So you've got two sets that are going to equal 180 degrees. So it's kind of an easy theorem. I didn't know that. I was trying to do the homework and I was like, I don't know how to find the missing value. And I looked at my formula sheet. I'm like, oh, they're 180. The opposite angles in the quadrilateral will be supplementary. If you don't know what supplementary means, write that they equal 180. Opposite angles are supplementary when they're inscribed. Why would that be? Yeah. I have to think about this. Okay. Again, if I move on and you're not quite ready, you can come get my paper off my desk once we start notes, or you can just come up and push the over arrow so you can finish writing the stuff. Okay. Here's some examples of what it might look like to answer your questions. Emery, on A, how would you possibly find the value of x? Okay, so look at your theorem. If you have a triangle inscribed in a circle, which we do, and one of the sides is a diameter, which it is, what do we know, what kind of triangle does it have to be? Yes. So how do you find x? The rest is just algebra. It's not always half. This could be a 3x and I would divide by 3. This could be a 5x and I would divide by 5. But the basic idea from these theorems is they're going to give you pictures of circles and you have to use the theorems to find missing parts. So, oh my gosh, it's a right triangle. Which theorem do we use? You look at your notes, you find the picture, and you start reading through it. Do I know anything about this? Okay, let's look at B. What have I stopped picking on? You, Addie. Addie, how do you start on B? What do we know about quadrilaterals that are inscribed? Opposite angles are supplementary. So, Addie, what's Z going to be?
80.
Because 80 plus 80 is 160.
Aren't the angle F and angle D the supplementary, or are they not?
Yes. These are supplementary. You still think it's 80? What does supplementary mean?
Oh, that they equal 180.
Yeah. There you go. Yes. Z is 100. You're up. He's ahead of me. Yes, 60. Because G, angle G, and angle E are opposites, And because of our theorems we wrote down, because there's no way we're going to remember all these, we know they equal 180. Okay, we're going to do 2 of these, and then I'm going to give you the rest of the time to work on your homework. Are you ready? Which one do you want to do? 4, 5, 6, or 7? Okay, let's look at 4. What's the measure of angle x? How do you know that? Yeah, so if you start looking at your theorems, if you have an inscribed triangle, we do, and one of the sides is a diameter, it is, then the side opposite is the 90-degree angle. Then how would you find this one? What is that, 50? Okay, so the triangles are all similar to that. The angle opposite the diameter is the 90-degree one. You ready? I think you guys are going to get off the hook. I'm running out of questions. Which one do you want to do, Jetta? We can't do 5, but we already did a triangle. 6 or 7? Okay. How would I find the measure of angle y degrees? They are supplementary. Some people really want them to be equal, so just make sure you're not setting them equal. All right, I think we're ready to go. Go grab your computers.